It's a quiet Monday evening on Mars, or at least what the colonists still call Monday. The two moons shine brightly, hanging low in the dusty pink sky. Across the harsh red dunes sits the Aurora colony. Inside the domes, we can sense life. Engineers adjusting machinery, scientists studying samples of Martian soil, and the faint glow of lights casting a warm, steady rhythm under the alien sky. How do you turn a barren planet into a thriving civilization? Deep within the domed cities of Mars, manufacturing facilities work tirelessly, transforming the planet's raw resources into the building blocks of a new civilization. Among them is Kai, a 32-year-old crystal engineer whose work is at the forefront of humanity's boldest dream, to colonize not just Mars, but the entire solar system, and perhaps one day, even more. The red glow of the pressure controls illuminates Kai's lab, signaling a minor error in the process of transforming Mars-extracted silicon into the core of modern technology. With a quick adjustment to the chamber's temperature, Kai resolves the issue and the system goes back to work. See, Mars is an ideal location for manufacturing silicon crystals for two key reasons. One, its regolith is rich in metals and minerals like silicon. And two, its surface gravity is just 38% of Earth's. These factors unlock exciting possibilities for low-gravity manufacturing, revolutionizing industries and offering unique advantages for a future Martian colony. But how can we get there? For Elon Musk and SpaceX, the answer lies in innovation, ambition, and a relentless drive to push the boundaries of what's possible. From reusable rockets to using Martian resources to fuel the journey. Every step of the mission to Mars is designed to make humanity a multiplanetary species. But this isn't just about technology. It's about survival, exploration, and the dream of a future where the stars are within our reach. This is Falcon 1. Falcon 1 failed more than it flew, with just 2 successful launches out of 5 attempts. Falcon 9, on the other hand, the evolved version of the rocket, has achieved over 400 successful launches and a 99% plus success rate. But the rocket that won't just reach the orbit, but forge a path to Mars, turning science fiction into fact, is called the Starship. Unlike the moon landing in 1969, Elon Musk's plan for getting to Mars is far more ambitious and complex. While Apollo 11 was a historic first step, Starship represents a giant leap. A leap towards a future where humanity is no longer bound to a single planet. The Apollo missions were a one-way ticket. Every Saturn V rocket was used once and then discarded at a cost of billions. Starship, on the other hand, is fully reusable. Its super heavy booster returns to Earth, ready to fly again. This reusability slashes the cost of space travel, making Mars missions not just possible, but practical. But now, let's see what SpaceX is actually doing with these rockets and what makes them reusable. This is Starship, a marvel of engineering made up of 2 separate parts, each with a specific role in the Mars mission. Together, they form a system designed not just to reach Mars, but to make space travel as routine as catching a flight. The journey begins with the Super Heavy booster, the first stage of the rocket. Packed with 33 Raptor engines, it generates over 16 million pounds of thrust, enough to lift spaceship off the Earth and into space. But here's the game changer. Once the Super Heavy booster has done its job, it doesn't crash into the ocean like the previous forms of rockets. Instead, it flips around, reignites its engines, and performs a controlled descent back to Earth, landing vertically on a launch pad or drone ship. This is the first step in making space travel affordable and sustainable. Meanwhile, the spaceship spacecraft, the second stage, continues its journey into low Earth orbit, the region of space closest to Earth, where satellites and space stations operate. But here's where things get even more interesting. To reach Mars, Starship needs more fuel that it can carry at launch. So, a second Starship launches shortly after the first, carrying nothing but fuel. This tanker starship docks with the first one in the orbit, transferring its propellant to top up the tanks. This process, called orbital refueling, is what makes interplanetary travel possible. With its tanks full, the first starship ignites its engines again, breaking free of the Earth's gravity and setting course for Mars. Powered by 6 Raptor engines, it carries everything needed for the mission: crew, cargo, and life support systems. As Starship approaches Mars, it faces its next challenge: landing on the red planet. Using its heat shield made of hexagonal tiles, it slows down as it enters Mars's thin atmosphere. Glowing red hot from the intense heat, aerodynamic flaps adjust to control its descent, and with a final burst from its engines, it touches down vertically on the Martian surface, ready to begin its mission. But the journey doesn't end there. The Starship is designed to return to Earth. And that's where the In Situ Resource Utilization, ISRU, comes in. ISRU, the process of using local resources to produce fuel and other essentials, turns Mars into a gas station for the stars. The fuel for the return trip, methane and oxygen, can be produced right on Mars. The planet's soil is rich in water ice, which can be melted and split into hydrogen and oxygen. Mars's atmosphere, which is 95% carbon dioxide, provides the other key ingredient. Using a process called the Sabatier reaction, a chemical process that combines carbon dioxide and hydrogen to produce methane and water, these resources are turned into fuel. Producing enough fuel for the return trip could take 6 to 12 months. During this time, the crew will be busy setting up habitats, conducting scientific experiments, and exploring the Martian surface. Once the tanks are full, Starship is ready to lift off again. But here's the key difference. Unlike the launch from Earth, Starship doesn't need a booster to leave Mars. That's because Mars's gravity is only 38% of Earth's, and its escape velocity, which is the minimum speed needed to break free of the planet's gravity, is much lower. This means Starship can launch from Mars using its own engines, making the return trip simpler and more efficient. This ability to refuel on Mars and launch without a booster is what makes Starship truly revolutionary. It's not just a spacecraft, it's a self-sustaining system designed to turn Mars into a stepping stone for humanity's journey to the stars. Why Mars? Why go through all these effort, risk, and expense to colonize a barren, dusty planet millions of miles away? The answer lies in the bigger picture. Mars isn't just a destination, it's a stepping stone, a testbed for the technologies and systems that will one day take us to the stars. It's about survival, exploration, and the dream of a future where humanity is no longer bound to a single planet. Earth is fragile. Climate change, asteroid impacts, and other existential threats remind us that our home isn't invincible. Mars offers a backup plan, a second chance for humanity. But it's not just about survival. Mars is a treasure trove of resources waiting to be unlocked. Its soil is rich in minerals like iron, silicon, and magnesium. And then there's water, frozen beneath the surface, waiting to be extracted and used for drinking, growing food, and splitting into hydrogen and oxygen. Mars could become a hub for innovation, driving advancements in science that will benefit life on Earth. So why Mars? Because it's there, because it's hard, because it's what we do. Throughout history, humanity has pushed the boundaries of what's possible, venturing into the unknown in search of new horizons. Mars is the next great frontier, a challenge that calls to the explorer in all of us. It's not just a planet, it's a promise that we can overcome any obstacle, and that the stars are within our reach.